Hindi na.
Fashion free, free. Give me fashion, give me boobs, give me fashion.
Genetically modified organism, or GMO, is the term used for an organism created through genetic engineering. Genetic engineering is an emerging field of science that was coined by Jack Williamson. Its process is the deliberate manipulation of the organism's genes where it may involve transfer of genes from the organisms. It is also the same process that we are using in cloning. Cloning is the sexual reproduction of an organism using a parent cell. GMO is used in different ways. We may not know that we encounter it in our everyday lives, but it is everywhere, especially in our foods that we eat. Here are the examples of common GMO.
So how does genetic engineering works? It is accomplished in 3 basic steps. First is the isolation of DNA fragments from a donor organism. Second is the insertion of an isolated donor DNA fragment into a vector genome. And lastly, the growth of a recombinant vector in an appropriate host.
The Center for Ecogenetics and Environmental, or CEH 2013, identified the following roles of GMOs in the food and agricultural industries. We have pest resistance, virus resistance, herbicide tolerance, fortification, cosmetic preservation, and increased growth rate. GMO also have non-food crops and some microorganisms which involve flower production, paper production, pharmaceutical productions, bioremediation, enzyme and drug production, and GMOs in the medical field.
Studies show some of the potential benefits of GMOs. We have higher efficiency in farming, increase in harvest, control in fertility, increase in food processing, improvement of desirable characteristics, nutritional and pharmaceutical enhancement, and reduce the use of fertilizers and pesticides. There are also potential risks in GMOs. Despite the promising claims of GMOs, the opponents of GMOs claim otherwise. For example, there are studies that show a link in the adoption of pesticide-resistant GMO crops to the significant growth of superweeds that became pesticide-resistant too. This caused additional problems to more than 12 million acres of farms in the United States. Opponents of GMOs have the following major concerns. First is, since genetic engineering is still a young branch of science, there are inadequate studies of the effect of GMOs to human and the environment. Second is, genetic engineering promotes mutation in organisms, which the long-term effect is still unknown. Lastly, human consumption of GMOs might have the following effects. They have more allergic reactions, gene mutation, antibiotic resistance, and nutritional value.
There are also potential environment risks caused by GMOs. Karki 2006 summarized the perceived potential environment risks caused by GMOs. The identified major risks are the following. Risk in gene flow, emergence of new forms of resistance, and secondary pest and weed problems. The combination of virus and bacteria to produce new pathogens.
GMOs are one of the most controversial areas of science. Genetic engineering is used in many fields, but even though medical applications like GM insulin are widely accepted, the debate heats up when it comes to food and agriculture. Why is that? Why is the same thing treated so differently? Let's try to get to the bottom of this and explore the facts, the fears, and the future of GMOs. In a nutshell, what is natural? Humans have been genetically modifying plants and animals for thousands of years. Maybe a few of your crops had very good yields. Maybe one of your wolves was especially loyal. So you did the smart thing and bred the plants and animals that had traits beneficial to you. Traits suggest an expression of genes, so with each generation, those genes got more pronounced. After thousands of years, almost every single plant and animal around us is vastly different from its pre-domesticated state. If humans have been changing genes for millennia, what makes a so-called genetically modified organism, or GMO, different? Selective breeding is basically hoping for lucky hits. Genetic engineering eliminates this factor. We can choose the traits we want, make fruit grow bigger, immune to pests, and so on. So why are people concerned about them?
are GMOs bad? Gene flow, meaning GM crops could mix with traditional crops and introduce unwanted new characteristics into them. There is a method that might guarantee complete prevention, but is a big anti-GMO argument by itself. Terminator seed. The idea is that they could produce sterile plants, requiring farmers to buy new seeds every year. The very concept of this, however, caused a public outcry, stopping the technology put to use. This brings us back to the intentional spreading of engineering DNA. There have been cases of GMOs growing where they weren't planted, and traces of modified genes found in foreign crops. But GM plants can run wild entirely. Many crops pollinate themselves, and all crops have to be related to mingle. There are also cultural methods like buffer zones to keep unintentional crossings at a minimum. But if it's possible in principle that a GMO could unintentionally cross with a non-GMO, is food that comes from GM crops different to food from non-GM crops? These questions have been a major concern from the very beginning. GM plants that are destined to be eaten are checked for possible dangers, and the results are evaluated by multiple agencies. After more than 30 years and thousands of studies, the science is in. Eating GMO plants is no more risky than their non-GMO equivalent. But what about plants that have been engineered to be toxic? Example, Bt crops, a gene borrowed from the bacterium Bacillus thuringiensis, lets engineered plants produce a protein that destroys the digestive system of a specific insect pest. The plant makes its own pesticide. The insect that eat it die. That sounds alarming. Pesticide sprays could be washed off, while the poison is in Bt crops is inside the plant. But actually, it's not a big deal. Poison is really just a question of different perspectives. What's harmless to one species might kill another. Coffee, for example, is a poison that kills insects but is harmless to us. Or take chocolate, it's dangerous for dogs but a pleasure for humans. Bt crops produce a protein that is tailored to the specific design of the digestive tract of certain insects. It's completely harmless for us.
Hey there! Credits to Life Nuggins. This is Ronbus, and he is good at everything like soccer. And I want to have a lot of friends like Ronbus. Exactly like him. In my world, it is very easy to clone. My animator can copy-paste and charan, I've got 20 more Ronbus. What if you want to clone your best friend or even yourself? How would that even work? Cloning is the process of producing a genetically identical copy of a living organism. It can be done on many scales, from replicating basic DNA to a complete genetic copy of a living thing. Scientists have cloned a batch of animals in the last 100 years, most notably the infamous Dolly the sheep in 1996. Now we've got cloned cows, horses, cats, and dogs running around, and just recently, 2 cloned monkeys joined the party. This part smells really bad, guys. Oh my god, if we could just clean some stuff up a bit. If we can clone primates just like monkeys, can we do it with humans? Most successful and well-known method of cloning full living things is somatic cell nuclear transfer. Scientists have an ovum from a female of the species they're cloning and remove all the DNA from inside. Then, they take the nucleus of somatic like a skin cell from the thing they want to and insert it to the egg. The egg is then implanted into a surrogate who carries the egg until it's born. Now, the scientists have cloned a non-human primate, but there's still a ways to go. The success rate of these monkeys was super low, as it often is with cloning. The scientists started out with 127 eggs and only ended up with 2 monkeys, meaning their success rate was only 1.6%. One of the biggest struggles with cloning primates has to do with spindle proteins. They're crucial in cell division and development. And in humans, they reside in the nucleus of an egg. So when the nucleus is removed to make room for the new DNA, those spindle proteins are removed too, making embryonic development that much harder. Say we found a solution to biological issues like this, navigated our way through the complex ethical implications, and successfully cloned a human. Would your clone be just like you? If you're 5'10" with brown hair and blue eyes, maybe your name is Jelly May. Who knows? You'd expect your clone to look the same, right? Well, you may be surprised to learn that your clone would look completely different. Your appearance is based on genes, yes, but it also depends on the fetal environment you grow in, and which are turned off and on. Your clone could also be very unhealthy. Many cloned animals suffer from defected brains, hearts, and livers, and immune system problems. In lots of clones, the tips of their chromosomes shrink quicker, meaning cellular aging happens. So your clone could be really sick and die prematurely. Plus, your clone could have a complete different personality than you do. While your personality is based on some genetics, it's also formed through experiences and upbringing. Just because Ronbus is super friendly, motivated, and like puzzles, doesn't mean his clones would be like him too. A Ronbus clone could be mean, dishonest, and hate puppies. So unless your clone had the exact same development and experiences you did, it really wouldn't be you. With all this being said in the previous videos, we hope that you've learned a lot. Thank you.